All right, we're going to take a look at lesson 4.3. We're going to talk specifically about two of our types of triangles, isosceles and equilateral. When we start looking at having equal sides in our triangle, there's certain properties, certain characteristics, and things that happen as the relationship between the angles and the sides. So we'll take a look at those. Obviously, our vocabulary we want to work on. The leg of an isosceles triangle, those refer to the congruent sides of an isosceles triangle. So because it has two congruent sides, you will have two congruent legs. The base of an isosceles triangle is the side of the isosceles triangle that is not a leg. So it's the side that is not congruent to another side. And then last but not least, the base angles of an isosceles triangle. So those are the two angles in an isosceles triangle that are opposite the two congruent sides found at the base. So a lot of vocab there. So let's talk about what that ends up looking like. So we have our two congruent sides. This would be our base, and these would be our legs. And so the base angles are opposite the two congruent sides. So these are what we call our base angles. They are on the base. So we talk about being opposite. This is what it means to be opposite or across from that. So the base angles, a lot of times our diagram are down below. Our base angles are going to be congruent to each other. All right, and so that's what we mean by our base angles. Theorem 4.3 tells us that if two sides of a triangle are congruent, then the angles opposite them are congruent. So we've got our two congruent sides right here. We need to look at the angles opposite those. So if AB, which is opposite angle C, is congruent to AC, which is opposite to angle B, then angle B is congruent to angle C. So if we have two equal sides, opposite angles are congruent. So equal angles and equal sides go together there. All right, so if we take a look at example 1 using that base angle theorem, find the measure of angle L. Well, we know that angle L is the base angle of the isosceles triangle. It's opposite one of our congruent sides. And so angle L and angle N have the same measure. And so if angle N is 52 degrees, then we know the measure of angle L is also 52 degrees. All right, now we're going to go back and talk about converses of base angles. Remember, we talked about converses a little bit in there where you kind of switch your if and your then. So if two angles of a triangle are congruent, then the sides opposite them are congruent. So we've got B and C, angle B and angle C being marked as congruent. So that means the sides opposite them are going to be congruent. So angle B is congruent to angle C, then AC is going to be congruent to side AB. Right, so example 2, the converse of the base angle theorem. We need to find the value of x. I see first when I look at this that I've got two congruent angles, S and P. So I'm going to look at the opposite sides, 12 and x plus 3. So TS is equal to TP. So x plus 3 is equal to 12. So we're substituting in values for TS and TP. This first blank here, the reason I know TS is equal to TP is the converse of the base angle theorem. All right, then you're going to subtract 3 from each side, and you get x is equal to 9. All right. So I want you guys to take a look at these, and I want you guys to do these on your own. So this is a do now, and we will check in class. This is going to go back to our example 1. This is example 2, and this is going to be example 2. So for those of you who come in and say, I'm confused, you need to be able to turn back to those and start using them. All right, so now we have our equilateral theorem. So if a triangle is equilateral, meaning all equal sides, then it is also equiangular. And that kind of fits with what we said in isosceles. The angles opposite the congruent sides were congruent. Well, if all of my sides are congruent, then all of my angles should be congruent. So if AB is congruent to AC, which is congruent to BC, then that means angle A is congruent to angle B, and it's congruent to angle C. We then have kind of the converse of that, and we call it the equiangular theorem. If a triangle is equiangular, then it is equilateral. So if I give you all congruent angles, then I know AC is congruent to AB and is congruent to BC. So I know if angles are equal, sides are equal. If I know sides are congruent, angles are congruent. All right. So let's take a look. Find the length of each side in the equiangular triangle. So if angles are equal, then that means sides are equal, congruent. So the angle marks show that it's equiangular, so the triangle is also equilateral. So that means 3x is equal to 2x plus 10. I'm going to subtract 2x from each side, so 3x, take away 2 x's, leaves you with 1x. That leaves you, after you subtract that from each side, that leaves you with just 10. So then, notice they're asking you to find the length. Once you find that, you have to substitute 10 in for x. We don't stop at saying just x equals 10, but we go and plug that back in. So we get each side of the triangle is 30. Now we can check that by saying this side is 2x plus 10. So if I do 2 times 10, which was the x value, and then add 10, 20 plus 10 is 30. So I'm getting 30 regardless of which side I plug that x in for. So the follow-up, we're going to compare example 2 and example 3. How are they alike? How are they different? So this one we will do together. Okay, so you guys can skip that for right now. We'll have some conversation in class about those. And it looks like we are done for this lesson. All right, we will see you guys tomorrow.